This video is the last in a series of videos introducing the concepts of vectors. In this video, we'll be discussing unit vectors. Now, unit vectors aren't used as much, say, in the beginning physics classes, but they become very important in future physics and engineering classes. So I wanted to introduce the topic here, and it'll help keep you more organized when problem solving as well. So what is a unit vector? Well, a unit vector is a vector. It has magnitude and direction, but it has special properties. First off, it only has a magnitude of 1. As well, it's dimensionless, which means it has no units associated with it. Now, you can turn any vector into a unit vector. We're not going to do this too much in introductory physics classes, but I think it's important you see how it's done. So let's take any generic vector A that has magnitude and direction. Now we're going to divide this vector by its magnitude only, so I got the absolute value signs. And that's it. Any vector divided by its magnitude gives a unit vector with a magnitude of 1, no units, and a direction that's in the same direction as the original A vector. To signify that it's a unit vector, we call it A with a little hat-shaped thing on top. So we actually call it A hat. And it's this little hat on top that signifies that we have a unit vector. So to sum up, we call it A hat with the little hat-shaped symbol on top. We have now defined a unit vector in the same direction as A. Now we want to look at 3 special unit vectors. So notice here I've drawn an x, y, z coordinate system with x positive to the right, y positive up, and z positive out of the page towards you. I've had to draw it a little bit in 3D. The way these axes are laid out is called a right-handed coordinate system, and it becomes very important in future vector mathematics. We don't have to worry about it as much right now. Now I'm going to define 3 special unit vectors. The first is a unit vector that points along the positive x-axis. I will call this unit vector I hat. There's no significance with the I, it's just the letter they started with. So this will be I hat. The second unit vector points along the positive y-axis. We will define this one as J hat. And the last unit vector will point along the positive z-axis. We'll call that K hat. To see how to use these, let's try an example in 2 dimensions with an x and y coordinate system. Here's a vector A, and it will have components ax and ay. Now we know I hat points along the positive x-axis, and j hat points along the positive y-axis. We can now use these 2 unit vectors to write vector A in component form. In this notation, we would write the vector A as ax I hat plus ay j hat. Writing it this way allows us to write it in components, but keep it separate. So everything in front of the I hat involves the x component. If ax is positive, you'd be pointing along the positive x-axis. If ax is negative, you'd be pointing along the negative x-axis. So this provides us a nice little bookkeeping system to write down a vector, but keep its x and y components completely separate. Writing vectors in this form with the I hat, j hat, k hat provide us with a nice little system for writing down a vector in components, and will make it a lot easier to do some of the vector mathematics, including some you haven't even seen at this point in the course yet. I'll just show you quickly that you can do it in 3D as well. In 3 dimensions, here's our 3D coordinate system, a vector A is drawn on it like this. As I can show with the lines on my drawing, a vector A that's 3-dimensional will have 3 components, ax, ay, and az. So in component form, you'd write it like this. A is equal to ax I hat plus ay j hat plus az k hat. Now we saw in class and in a recent video that when adding or subtracting vectors, you can add or subtract their x components separately and their y components separately. We'll show you why it's a little easier to write this down in unit vector notation. Let's try an example with 2 force vectors. There's vector A, 5.0 newtons I hat minus 4.0 newtons j hat, and B, which is negative 3.0 newtons I hat plus 6.0 newtons j hat. Let's try to add A plus B. So I'll write the vector A in component notation and the vector B in component notation right underneath it, and then I can add these two together. So now I can just add the x components together to give 5 minus 3 gives you 2.0 newtons I hat. Similarly, for the y component, we just have to add negative 4 to 6 to get plus 2.0 newtons. So our final answer, A plus B, is 2.0 newtons I hat plus 2.0 newtons J hat. Let's look at a slightly more complicated example. This time we'll calculate A minus 3B. Like before, I'll write the vector A, and then underneath it I'll figure out what negative 3B is. So negative 3 times negative 3.0 newtons in the I hat gives us positive 9.0 newtons. And minus 3 times 6 newtons will give us negative 18.0 newtons J hat. And now we just have to add the column of I hat together. That gives us 5 plus 9 will give us 14.0 newtons I hat. And if we do the J components, negative 4 plus negative 18 minus 22.0 newtons J hat. Using this vector notation is not only great for solving subtraction and addition problems, but later on when we do vector multiplication, dot products and cross products, you'll see it works really well to keep everything in I hat and J hat. That brings us to the end of this video and the video series on vectors. I hope you've enjoyed watching, and if you wish to subscribe to my channel, you can do so at the link right here. Well, thank you for watching. Have a great day.